Good evening, everyone. Back with another video. It's Sunday evening, about 9:30 p.m. Kids are in bed. It was a good weekend. Tonight, I'm going to work on some more Python cones. So kind of switching it up from the networking stuff. And I want to make a bit more progress through these. We're up to 13 subscribers now. So thank you, everyone, for watching. Let's get started. All right, so let's see. I'm in the Koans directory that we originally downloaded. And if you recall, we need to say Python 3. Let me make this bigger. There we go. Python 3, and then we need to run the contemplate koans.py file to see where we are currently at. And our error message is here. Says file user showtop programming Python Koans master Koans about none.py. So it looks like last time I think we were in about asserts, but we must have finished that. And so we can do about none. I don't know why that is not showing up. Let me actually do this. I will open the full directory here. I'll do this and then open. And now I should, with the full project in scope, be able to open up about underscore none. All right, and then jumping back over to our error. We were at line 14 in about none.py. So let's just read through this. Obviously a Python file based on about nil in the Ruby Koans. Okay, so from the Ruby programming language, which we could do next. From runner cone import star, class about none. Okay, so we've got, again, a series of tests that teach us about this concept of none in Python. So test none is an object. Unlike null in a lot of languages, we're going to test that none is an object. All right, so none being an object, it's a structure with maybe some abilities to do things, and it has some characteristics about itself. That's typically what an object is. Unlike null in a lot of languages. Okay, self-assertion is instance. Let's say maybe assertion none is an instance of none object. Let's run that and see what it does. All right, so that seems to be incorrect. You have not yet reached enlightenment. Assertion error, none does not equal true. All right, so assert equal. Oh, I see how it works. Okay. So we are asserting that none is an object, unlike null in a lot of languages. Okay, so the assertion, basically, assert equal, the argument on the left has to resolve to equal the argument on the right. And so the argument on the left being true, this argument on the right needs to resolve to true. And so we've got a method here called isInstance that says, okay, give me two things, and if the first thing is an instance of the second thing, return true. So that's what's going on here. Now an instance. Well, an instance is kind of like a copy of something. Let's say we have a class called dog, and we could have many instances of dog. Like one instance of the class dog could be German Shepherd, or another instance could be a poodle. And so an instance is like a stamp of a more general thing, typically. In this case, none is a type of, or is an instance of, object. Let's run that and make sure that all of these resolve to be equal on both sides and therefore pass. It looks like they did. All right, so now we're thinking about none. Okay, test none is universal, has damage or karma. All right, so we've got an error, a different one. Line 18, let's go there. So we're here. Test none is universal. There is only one none. Okay. Test assert equal. None is none. None is none. Okay. I'm going to say true. All right, that passed. So what's happening here? Well, again, we have this test that's called test none is universal. There is only one none. All right, and then we're going to verify that these two arguments passed to this assertion, assert equal, are equal, which makes sense. All right, so true, okay, is true, fine. Now, none is none. Well, I think if we say none is none, it's saying that, there's only one instance of none, which is kind of far out and interesting. One thing I like to do potentially is go to Python 3 to our little IDE here, and I'm just curious if I in here say none is none, if it returns true, and as you can see it does. So can we say none is 3? No, that is false. Can we say 3 is 3? And that is true. So there's some kind of syntax available to us where we can say something is, and like the English is, something else. And if they are the exact same thing, maybe perhaps the instance or the literal instance of that thing, true is returned. So kind of interesting there. All right, so test what exception do you get when calling non-existent methods? All right, so again, let's say we have our dog class again, and we decide that we want to make the dog bark. And we call dog, some instance of dog, let's say my dog.bark. And bark doesn't exist. Bark is not yet implemented as a method on our class or on our object. What error is going to be returned? I think this is what we're trying to figure out with this particular test. So test what exception do you get when calling non-existent methods? Okay. What is the exception that is thrown when you call a method that does not exist? Hint, launch Python command console and try the code block below. Don't worry about what try and except do. We'll talk about this later. Try none dot some method none does not know about, except exception as x, ex2 equals x. All right, well, let's do this try. Well, let's do exactly what they say. So we go into our little console here. We'll paste that in and press enter. And the reason it did not work is because our indentation is incorrect. So let's do this. Let me just write it out here. Why not? Remember, we need to have 4 spaces to indent in Python. All right, and then I'm going to go back. All right, and then 4 spaces for the next line. And I think we should be able to run it. Okay, and nothing happened. What exception has been caught? What is EX? EX2. Okay, so here it is. So what happened here? Well, we tried some piece of code, and I think, like they said, we'll talk about this later. And we called a method, some method none does not know about, okay, on none. And then, as expected, an exception was thrown. It was stored in a variable, and then that variable was renamed or named ex2. So then down here, I was like, okay, what is ex2 currently? And ex2 is the exception that was thrown. So it would appear an attribute error is thrown when an object is called, when a method is called an object that is not yet implemented on that object. All right, so we want to say attribute error. What exception has been caught? Need a recap on how to evaluate class attributes? Do we? We can go look at it real quick. Let me pull up a browser window here. All right. Class attribute, inspecting the class type. Some Koans may ask you for the class attribute of an object. All right. What does class attribute do? It tells you what the class type is for a given object on the left-hand side of the period. Let's look at that for a string object. The Python console IDE or idle and run this, Batman underscore class underscore. And I would expect that to be a string. Okay, so basically this is just type of in Ruby, or it just tells us what class the thing before is. Classes with namespaces, exception classes, okay, which is what we just saw. All right, so the class attribute. Let me jump back onto here. And let me say ex2, and we'll say dot underscore underscore class. And what is it? It is a class of class attribute error. Okay, so it's of the attribute error class. All right, interesting little side, I was going to say side hustle, no, side quest there. Okay, so ex2.class is equivalent to what did we just say? And I'm going to go back and look at it. Class attribute error. Now let's see, how do I need to write this? Let's see. I'm just going to maybe take this whole thing because we already ran it in the IDE here. IDE being the integrated development environment, which is, I wonder if I should run this as a full string. I don't know about that. Let's see what it does. Okay, so we need to get out of this and run, oops, exit and run contemplate comes up high. Okay, we were about none. All right, I think I was right not to put it in a string. Although the syntax looked a little weird, but because of the highlighting in Sublime Text, but I think that's okay. Yeah, it is a little weird. So maybe single quotes. No, it doesn't like that either. Maybe I should just say attribute error. Attribute error. Let's see what it does with that. Okay, that worked. All right, so although the output shows something not quite equivalent, where did I put it? Here. So ex2.class is class attribute error, and we got the brackets and the single quote, the class keyword, but here, no, where were we? We only needed the actual class, so interesting to note that. What message was attached to the exception? Hint, replace underscore underscore with part of the error message. All right, so ex2 args 0. Let's see. Well, what error message was attribute error? Oops. None type object has no attribute, something, something, something. All right, let's see what this is all about. Hint, replace underscore underscore with part of the error message. Okay. Oh, assert regex. I got it. So let's just do this. Let's get rid of this. Get rid of that. All right, and let's see if that regex matches. Yes, it does. All right, so what's happening here? Well, this is a new assertion. This is assert regex. And basically what it says is like, okay, the thing on the left is going to resolve to a string or some text. The thing return true if that text returned by the thing on the left is some subset of the text on the right. I think that's what's happening here. So they use a regular expression, and I think they're just, it under the hood just uses a regular expression, meaning like match on some text. As long as some text matches on both sides, this will return true. Now if I, let's see, get rid of this and say foobar, I would expect it to return false or return an error. All right, we're back to line 44. Okay, regex didn't match. Foobar not found in. Okay, so foobar is not some subset or subtext of the full text there. Okay, so oops, command Y, no. Command Z, no. Command U. Well, apparently I don't know my commands here. Basic text editing commands. Let me go back and just grab this silly old thing again. All right, and run to make sure that we still passing, and we're down to line 50. Okay. All right, last thing for this file. Is this right? No. What in the heck? Oh, it must be. Weird. All right, test that none is distinct. None is distinct from other things which are false. Okay, assert equal something. None is not 0. Okay, so we're going to assert that none is not 0. Okay, and the next is none is not false. So if it's true that none is not false and none is not 0, then these will both pass. All right, so let's just go to the IDE again. Python 3. And let's say it. None is not 0. That is true. None is not false. All right, so let's do none is not none. That should return false, okay, because none is none. None is not some string. Food. That is true. None is not some string food. Okay, so none is a unique thing. It's distinct. It's not a true or false, oh shoot, what do they call them? I can't think of the word off the top of my head. What are Booleans? It's not a Boolean. It's not true or false. It's not a string. It's just like own thing. I think that's what it's getting at there. All right, so let's run this again, and we get to a new file, I would believe. Exit. Run the contemplate Koans. Okay, so we've made it out of the thinking about or testing, thinking about nil, test none, thinking about none file, and now we're thinking about lists. All right, so let's do that. Let's do that. Maybe we can wrap up after we finish that. Some interesting quote here. Although never is often better than right now. Although never is often better than right now. I don't know if I believe that quote. This quote says, you have completed 9% Koans, and 3 out of 37 lessons. You are now 275 Koans and 34 lessons away from reaching enlightenment. Although never is often better than right now. makes you wonder. All right, so about lists. Let's do Command T, start typing about lists in our editor here in Sublime Text. Get rid of that old file. And we will go back to our message and say, okay, we were on line 14 in about lists. So we're here. So again, more Koans based on about arrays in Ruby Koans. All right, so in Python, lists of things are called lists. In Ruby, they're called arrays. So class about lists. The first one, test creating lists. Okay. So on line 12 here, we've got a variable called empty list, and it is equal to some list method. I assume we'll create a list. All right, and then we got two assertions. Assert equal that list and type empty list. Okay, so assert equal that the type of the empty list thing, whatever sits in this variable here, is of type list. And then assert equal len empty list. So that's length. So let's assert that the length of the empty list, I assume because it's empty, will be 0. So let's run that and see what we get. All right, so we are now down to line 24. Looks like we did, in fact, learn something and moved on to the next test. So that's how we create lists. We can say list. Let's just jump into the IDE and experiment a bit here. Python 3, and you know what I will do? I'm just going to not do that. I'm just going to open a new window and run Python 3 and just have our IDE going right here. All right, and then we're going to say empty list equals list with no argument. And then I'm going to just type what is empty list right now. And it's just an empty list. All right, run this again. Line 24. Okay, so test list literals. All right, so now on line 17 here, we've got a nums variable set to an empty list constructor. And we're going to assert equal that the thing stored in nums is an empty list. All right, now nums 0 colon equals 1. All right, so I'm just reading this line out loud. Assert equal 1 nums. Okay, so I think this is kind of interesting, but I think what we're doing here is we're taking our list called nums on line 20 here where my cursor is. And in the first position of that list, we are inserting a value of 1. And then we are inserting a value of 1. And therefore, after we've inserted that value of 1, we're able to say that now our list is a list with a 1 inside, and that is the equivalent to what is in the variable nums. So now on line 23, in the second position, one thing worth pointing out, nums 0, nums 1, the first position in these arrays or in these lists is always the 0th position. The second position is 1, etc. So they begin with an index of 0, zero-based indexing, I believe is what the term is for these lists in Python. So that's very important to remember. Because like, oh, I'm going to grab the first item in this list, and you want to grab it by its index, like you're doing here. You want to make sure that if you want the first one, you got to pass 0 instead of 1, which would be the kind of like the logical thing you'd expect. All right, so now in the second position in the list, we've inserted, looks like the integer 2. So we're going to say self assert list equal. Okay, so whatever is currently in nums, what do we believe is in nums? Well, nums is now a list of the numbers 1 and 2, the integers 1 and 2. All right, so now let's see this. Nums.append 333. Assert list equal. Okay, so we've taken nums, we've added the integer 1 to it, and then we ended up with this. We've added the integer 2 to it, and we now have this. And now we're going to append 333 to it. And append just means insert this value at the end of the list. All right, so 333 is equivalent to num. So let's run those and make sure that they all pass. And they do. So we are down to line 32. All right, so test accessing list elements. All right, so we've got a list, or we've got a variable called noms, and it is set to a list of strings. And those strings are peanut, butter, and jelly. So 4 strings in a list that are accessible by their index, and the index of the first item in any list is 0. So keep that in mind. All right, so assert equal, self assert equal, okay. Now what is at the 0th position in the noms list? Well, that's the string peanut. All right, now let's just go ahead and run that and make sure it passes. It does. We're on to 33. Okay. So what is the item at the 3rd position on the in the noms list? All right. Well, the 3rd position, we have 0, 0th position, 1st, 2nd, 3rd. So I'm going to guess that that value should be the string jelly. All right, so let's run it. Line 34. Okay, we're at 34. So that worked. All right, so now the negative indexes, negative indexing. All right, so this is like what is in the position first from the right. So from the end of the list, going backwards, what item is first? I think it's going to be jelly. We'll run it and verify that suspicion. And let's see. I think I was right. Great. All right, now, same thing. Starting from the far end of the list over here and traversing 3 items, what is there? But notice we start with -1 coming from the end of the list. So -1, -2, -3. I'm going to assume this is butter. Let's try it. All right, and I think we were correct. So made it through all those. Okay, so this is important. Let's just grab this, go over to our IDE, and just mess around with it a little bit. All right, so we've got noms, peanut butter, and jelly. So we've got a noms list. And what is noms right now? Okay, so let's do noms.append, and we'll append a new string, and it'll be with. And again, I'll put bananas. All right, now what is noms now? Well, I expect noms to be a list with the strings peanut, butter, and jelly with bananas. So let's do noms. And sure enough, it is. That's good. All right, so what's at the -1st index of noms currently? I would expect it to be bananas. What's at the first index of noms currently? I would expect it to be butter, not peanut, because peanut is at the 0th. Let's see. And let's see what is at the 0th. Peanut, okay? So we can access items in a list using this syntax, this bracket syntax. It almost looks like a list itself. We can call this on lists and get the item that exists in the list at that particular index. So that is very useful. All right, test slicing lists. So we've got a list made up of peanut butter and jelly strings. All right, we're going to be slicing this list. So slicing is basically how it sounds. we're going to like go from one index to another in a list and return that slice or that chunk of the list defined by the two indices or the two indexes. I don't know what the proper plural is there. All right, so I'm going to assume, I'm not sure how this really works, but we're going to find out. So noms 0 to 1. So give me a slice of noms from the 0th index to the first index. Now, I don't know, A, if it's inclusive, meaning will peanut and butter be returned with this, or just peanut, or if it's exclusive. I also don't know if it's just a new list, or if it's two strings, or how that's going to work. So I will assume that it's inclusive, and it's going to return a new list with the sliced items present. All right, so I'm going to say butter. And let's see if that was correct. Jump back over and run it. So we are about list line 40, and that was incorrect. So let me see about if it's just this. All right, we made it to line 41. So what did that teach us? These indexes are, they slice a list, a piece of a list off, put it in a new list, and return that. And they are exclusive, meaning up to the second index, but not including that item, okay? So now let's try it again. So 0, 1, 2. So from 0 to 2, but remember, exclusive. So I'm going to expect this to be peanut butter in a new list. Peanut, and then string butter. And let's run it and see what we get. We passed. Okay, line 42. All right, so that suspicion was true. All right, now, what if we do from 2 to 2? Okay, so 0, 1, 2. I'm assuming this will be and, because it's from one index to the same index, and it seems logical that it returned will be the thing there, but it could be wrong. Let's see. All right, 42. Oh, 42 is wrong. Okay, what do we do? So it's an empty list. That seems bizarre to me, but it's true. So apparently when you slice an array or slice a list from one index to the same index, nothing is returned. Interesting. All right, so now what if we slice a list, I keep saying array from Ruby. What if we slice a list all the way to an index that doesn't exist? Will we return an error? I would assume we will, but maybe we'll just get the rest of the list and it'll just stop once it can't go any further. So let's try that. So we go from 0, 1, 2. So we're going to go from and then finally jelly. And we can't go any further because there's only 3 indexes in this whole list, but this slice is trying to go out to 20. So let's see what this does. Line 44. All right, so that worked. I did not return an error. Now what if we start from an index that we don't have and go to the first index? So is that going backwards? I don't even know how this would work. I'm going to assume that's going to return nothing. Let's try. Line 45. Yeah, so that returned nothing. What if we start on an index we don't have and go out to an index we don't have? I have to assume that returns nothing. Unless maybe it's an error. Nope. All right, that was good. All right. What if we start at an index we don't have and go to the beginning? I assume, again, it's nothing. All right, and that was good. So we made it to line 51. So these are all done. So that was test slicing lists. Test slicing to the edge. Okay, so we've got variable noms set to a new list. Assert equal. So I think this is slicing and some shorthand form of saying, okay, give me everything beginning at some index all the way to the end of the list. So beginning at 0, 1, 2. So I think this will return a new list called or with the items jelly. Oops. And let's run that. 52. Okay, we passed. All right, now, again, this is shorthand, I believe, or the syntax for giving me everything in a list up to the index, starting at the beginning up to the index, so 0, 1, 2. So I'm going to go ahead and assume it's also exclusive, and it's going to return the 0th item and the first item, but not the second, butter. And that is correct. All right, moving on. Test lists and ranges. Okay, assert equal range type range 5. All right, so we've got this method that we can call called range, and it looks like we can pass it an integer, and it's going to return a range. And that thing that it returns is of type, or of class type, range. All right, that's what this first assertion does. Assert not equal. Okay, so we call range, we give it 2 items, 1 and 6, assuming we want a range of numbers 1 to 6, maybe. Assert not equal 1, 2, 3, 4, 5. So these two things are not equal. Maybe it's supposed to be 1, 2, 3, 4, 5, 6. So let me just first of all go over here and mess around with range just a little bit. So range 1, 2, 6. 1, comma 6. Okay. So if we do no, that's false. Okay, so a range is not a list, apparently. A range is not a list. All right, assert equal list range 5. All right, so maybe we need to convert it to a list to make something like this work, where we get a list of items back from our range. I think that's what's happening here. So first of all, let's try that. So what's just range 5 return? That returns a range 0 to 5. Okay. And now if we say list range 0 to 5, not lust, that's not right. Command control Y, command Y, no. How do I jump to the end? I don't know in this IDE how to jump to the very end of a line. So a range 5 is exclusive as well. It doesn't include the index or the item, the integer. Actually, in the argument here, actually the parameter here, but everything up to it. How, I'm Googling, how to jump to end of line in Python 3, not IDE. What do they call this thing? An idle. Control E. Let's see. There we go. Control E. Control Shift E. No, how do I go back? How to jump to beginning of line in Python 3 idle. Home, Control A. All right, so Control E, Control A. Good to know. Let's see, where is the thing? All right. A couple more and we should be good to go. Where are we at? We're at 40 minutes. Okay. All right, so the range, the list, we've converted our range 5 to a list. And what do we get? We get 0, 1, 2, 3, 4. We've done the same thing for our range 5 to 9. And I'm going to assume that this is going to be 5, 6, 7, 8, not including 9. Let's run those and see if they pass. So we get a 61. Yes, those both passed. So that's interesting. So a little bit about ranges and lists. You create a range, you pass it to the list method, and that's how you get a list back that range kind of defines. Test ranges with steps. Now that's interesting. All right, so it looks like we can do a range, and then we can define how many, I guess how many, the value of each step down the list is maybe the best way to say it. I'm not really sure. Through the items, or I don't know. Well, it'll be clear in a second, I hope. All right, so I'm going to assume this means going by ones down from 5 to 3 by ones, and it's going down because we're negative, I'm going to assume, not including 3 because they haven't been inclusive yet. So let's see what this does. 62. All right, so that was correct. So that was a good educated guess, but descending by ones, because this is -1, descending by ones from 5 to 3, from through the range 5 to 3. All right, so this one is assuming going to be go up, ascend by 2s from 0 up to, but not including 8. So I'm going to see what we got that. 0, 2, 4, 6. Let's see if that's correct. And it is. Sweet. All right, so from 1 to 8 by 3s, not including 8. All right, let's try that. So we got 1, 4, 7. Is this correct? 64, yes it is. All right, so we're doing 5, from 5 to -7 down by 4. So descend from 5 to -7. 5 by 4s. 1, -3, and not including -7. That seems to have worked. Finally, from 5 to -8 by 4s, not including -8. So we got a list. 5, 1, -3, -7. And that is correct. Now to 70. Test insertions. So we've got a variable called night, and it is set to a list with 3 strings in it. You shall pass. Then it looks like on a list we can call a method called insert that takes 2 arguments. The first appears to be an index or a position in that list, and the second appears to be the item you want to insert. So if that's the case, let's see what we can figure out. So we've inserted at the second index in the night list the value not. All right, so what does night then equal? Well, let's go grab this. And then in 0, 1, 2, I have to assume it's going to be you shall not pass. All right, so you shall not pass. Let's see. 73. Okay, that worked. So one thing of note, though, this index, you're inserting the thing before it. All right, so remember, our original list was 0, 1, 2, and they're saying, okay, we inserted something at 2. Well, that thing goes before 2, not after. Night. Okay, so again, we're inserting something in the 0th position of our original list. Actually, I take that back. It's changed. So I'm going to assume this is going to be all of this now. All right, and then at the 0th index, I'm going to assume we're going to have the key or the string Arthur, comma, space. Let's see if that passes. And it does. All right, so moving on. So now we can know, we know how to insert items into a list at particular positions. So we had a bit of that before, but now we can do it via this method that just very clearly states insert. Test popping lists, okay? So we've got a variable on line 76 here called stack, and it is set to a list with 4 integers, 10, 20, 30, 40. And we have appended to the last position in that stack list, the list with the variable name stack, the string last, okay? So we're going to say, we're going to take the value that we originally started with, and then remember we appended to it the keyword or the string last. And we're going to make sure that that's what the new stack equals after this process has occurred, and that is true, it does. Okay, so popped value. All right, so popping means popping the final item off the list. All right, so if we pop the final item off the list, that item, the popped value, is probably going to be the string last, and it modifies the list, I assume. It's possible that it doesn't, so we end up with a new list very similar to the one we started with, 10, 20, 30, 40. So no presence of the string last. Let's see if those pass. And we're down to 86. So yes, they did. All right, so now popped value equals stack pop 1. Okay, well, stack in its latest form is just 10, 20, 30, 40. And we've taken it and we've popped 1. And I actually don't know what the 1 would do there. Maybe it's picking a particular position to remove. So let's see if the popped value is 20. Remember 0, 1. If we're popping maybe the first index, that would be the integer 20. Let's see what we do with that. 87. That was correct. All right, so then what remains of stack? Well, I think it's now a list with 3 integers, 10, 30, and 40. Very interesting. Let's see if that's the case. Yes, it is, because now we're down to 101. Notice that there is a pop but no push in Python. Part of the Python philosophy is that there ideally should be one and only one way of doing anything. A push is the same as an append. To learn more about this, try typing import this from the Python console. Weird. Import this. Import this. Weird. The Zen of Python by Tim Peters. This is cool. Maybe is Tim Peters the creator of Python? Who created Python? No. Guido van Rossum. Who is Tim Peters? Python. Tim Peters is a software engineer. The Zen of Python. In 1999, a software developer and major contributor to Python named Tim Peters wrote The Zen of Python. It established 19 aphorisms, concise or forcefully something, something, something. All right, so this was written in 1999. Very, very interesting that that's accessible by typing import this. It's kind of a little Easter egg. Let's read it. The Zen of Python by Tim Peters. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts. Special cases aren't special enough to break the rules, although practicality beats purity. Errors should never pass silently, unless explicitly silenced. In the face of ambiguity, refuse the temptation to guess. There should be one, and preferably only one, obvious way to do it, although that way may not be obvious at first unless you're Dutch. Now is better than never, although never is often better than right now. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea. Namespaces are one honking great idea. Let's do more of those. Very interesting. So a little Easter egg from many moons ago. So let's go back to where we were. Learned something there. Test making queues. So a queue, to me, looks exactly like a list. So we've got a variable called queue, and it's set to what appears to be a list, 1 and 2, with integers 1 and 2 inside. Q.append last. All right, so what does our Q equal now? I assume it equals 1 space 2 space last, since we appended last to it. Let's run this. We're on line 104, so that is in fact correct. Popped value equals Q pop 0. So we pop the value at the 0th index out, and I'm going to assume it is 1, or maybe it's a list with 1 inside. Let's see if that's the case. 104, that was not the case. So maybe it's just 1. Let's try that. 105. Okay, so now what seems to be happening is if we pop something from a queue, no, that's incorrect. It looks just like a list. So far, there's no difference to me between a queue and a list. And now the queue equals, I think, 2, and then the string last. Let's see if that's the case. And it is, because we are back to a new file. So everything is passing in here. Note, popping from the left-hand side of a list is inefficient. Use collections.dequeue instead. Very interesting. Okay, that was a fun little exploration into some very important data structures in Python. So we made it through thinking about lists and thinking about none, and learned about how to slice, how to insert different things, append and pop different things, so manipulate lists in different ways. One, I think, key central thing to be conscious of is that when we create something like a list and then we modify it, its state or its composition changes as it's modified. So whatever we stored in nums here, for example, is not what it exists stored in nums here on line 26 after all of these changes have occurred. So the object gets modified and turns into something different along the way. It doesn't remain static. Okay, that is all for tonight. I hope everyone has a good week. Happy Sunday. I'll probably be back this week doing another networking video on DNS. So look forward to that. All right, have a good night.